Okay, so first one then. Whenever you're identifying organic molecules, you have to, got an answer from Zoe. Butane 2O is correct. So you're looking for the longest carbon chain with the functional group. So clearly it's 1, 2, 3, 4 carbons long. So it is bute of some description, and it is a ketone. So Zoe has named it as butane 2O, which is absolutely spot on. It's a ketone because the C double bond O, the carbonyl group, is in the middle of the chain, and it's on the second carbon. So that'd be carbon 1, 2, 3, 4. I'm just going to put the 2 in brackets, because technically that locant, which is just the number to denote the position of the ketone group, is not needed. Because if I just said butanone, all right, it'd have to be 4 carbons, and the carbonyl group would have to be in the middle of the chain. So there's no other place it could be. And don't forget dashes between letters and numbers. All right, so always dashes there. Next one, this could be interesting. Did anyone get the next one right? Well, it is 1, 2, 3, 4. It's 4 carbons long, and it is a halogenoalkane. So I know that it's going to end in butane. But now here's the question: which end do I start numbering from? All right, I can number from this end, 1, 2, 3, 4, or I can number from that end, 1, 2, 3, 4. And the general rule that you number from the end nearest the first branch. But in this case, there's branches on the second carbon from either end. So number from this end because there's more branches on this carbon. And I'll show you why that's important, because it'll keep the numbers as small as possible. So we've got, let's have a look at this. So 1, 2, 3, 4. So this one has got 2 iodines on the second carbon. And, okay, 1 chlorine on the third carbon. Which one am I going to name first? Well, we named all the branches alphabetically. So C comes before I, so it's 3 chloro. And then 2, we'll space it, 2 diiodobutane. Okay, 3 chloro, 2 diiodobutane. If it was the other way round and it was 2 chloro, 3, you can see that the numbers here are slightly bigger. You've got 2 3s and a 2, which is bigger than 2 2s and a 3. So again, try and keep the numbers as small as possible. And if you, general rule, if there's multiple branches, number from the end nearest where there's more. This one then, we've got an alkane. All right, nice easy one. Okay, so what do we call this alkane? Any ideas? Yeah, well, people are typing it. I'll walk you through it. So we've got 1, 2, 3, 4, 5, 6. So it's hexane. It is a hexane derivative. And I'm going to number from the end nearest the first branch for this one. So it is, what branch have I now got? What are these 3 things? Well, it's just an individual carbon. Don't forget there's no hydrogen shown in the skeletal formula. So they're actually methyl groups. So it would be 2, 3, 4. And here's where students make a classic mistake. They go straight for methyl. They go 2, 3, 4, methyl hexane. Well, no, if you're saying there are 3 methyl groups, you have to use a prefix to denote that. So 3 is tri-methyl hexane. Okay. This one, all right, I'm sure that nobody in their right mind has named it this. So I'm just going to, so it is, right, got it. So it's 1, 2, 3, 4. So it's bute 2ene, and there are 2 fluorines on the second and third. So it is 2, 3 difluorobute 2ene. And I know nobody in my class will have actually put that, because that is obviously the wrong answer. 2,3-difluorobutene, it looks like that, yes, but where are these two fluorines, which are the priorities either side of the double bond? It is E, 2,3-difluorobutene, all right? Very popular sort of AQA trick. Well done, Fab, yeah. Very popular AQA trick, that. And the number of students that just go for that is quite a lot. So number 5, simple, alcohol. All right. How many carbons? 1, 2, 3, 4, 5. So pentan, 3 of. Okay. Now number 6, you would have been taught how to actually answer these last year, but can you remember? Because it is a ketone, but it's a multiple ketone. There's actually 3 ketone groups in this. So how do we go about naming this? I hear you ask. Right. Well, first thing is longest carbon chain. What have we got? With the functional group, so that'll be all of them. There are no branches. Okay, so I've got to name everything in there all at once. So which end am I going to number from? Well, if I number from this end, 1, 2, 3 is the first one I'll come to. If I number from this end, 1, 2. So I'm going to obviously keep the numbers as low as possible. So it's hex. Okay. Now, if there was just one ketone group, you'd call it hexane 2-one, hexane 3-one, hex, and so on and so forth. But because there are multiples, all right, there are multiple ketone groups, you have to include the letter E. It is hexane, and now you have to give the location of all the ketone groups. So it'll be 2, 3, 4, because that's where they are, second, third, and fourth. And here's where students get so cocky here as well. They go, yes, I've got it. I know it's a ketone, hexane 2, 3, 4, -one. No, just like before, there are 3 ketone groups, so you need a prefix to denote what 3 actually is. So it is trione, hexane 2, 3, 4, trione. Okay. This one down here, you'll see this drawn differently in different textbooks, because sometimes, even though they shouldn't, you'll see the H drawn in as well. And we never really like to see carbon-hydrogen bonds using skeletal formula. So I've given the game away there a little bit. It is in fact an aldehyde, because the C double bond O is at the end of the chain. All right, so let's have a go at naming it then. So what's that purple bit then? We'll ignore the branches for now. It's 1, 2, 3, 4, 5. It's 5. So it's an aldehyde, sorry. There's 5 carbons. The aldehyde's always at the chain, at the end of the chain, so you don't actually need a number for it. So it's 5 carbons, pent-an-al, not pentanol, pent-an-al, all right? Pent-anal, okay? So now we've got to name the bridges, or the branches, sorry. So what I've actually got, well, this is a simple methyl group, and this has got 2 carbons. So 2 carbon branch is an ethyl group. Okay. You don't have to, with an aldehyde, worry about which end you number from. You always, the aldehyde group is always carbon 1. Okay. So the question is, am I going to name the methyl first or the ethyl first? Well, it's got to be alphabetical, so it'll be 3 ethyl, 2 methyl, and don't forget there's no gap, so the letters nice and joined up like I've done. Pentanal, all right? And this final one, hopefully you can identify at least the functional group. So what have we got here? It's a Kuha at the end, which is a carboxylic acid. So how many carbons long is it? 1, 2, 3, 4, 5, 6, 7. And 7's always sort of like the prefix that a lot of students seem to forget. Hept. If it's 7, it is hept. So it is heptanoic acid. So I'll draw it underneath. That's fine. Heptanoic acid. Obviously, it's 2 separate words, so I've given you a gap there to show that. And then, what branches have I got? Well, I've got, that's an ethyl group, that's an ethyl group, that's a methyl group. So again, just like before, what am I going to name first? All right. Okay. Does anyone think they can fill in the rest of that? So I've given you the end of it, all right? Good effort, good effort. Look closely though, Fab, because the third carbon, these aren't methyl groups, they're ethyl. You see there's a joint there, so it's 2 carbons. And that's an ethyl group, okay? So have another go. Three diethyl 4-methyl pentanal. Not quite. You got the names of the branches, right? Just the, yeah, there it is. Well, Zoe. So it is 3,3 diethyl. So 3,3, 2 ethyl groups. So are there 2 ethyl groups on carbon 3 and carbon 3? Yes, there are. And then 4-methyl. I have to get rid of my hexanoic. Heptanoic acid. All right. Potentially, you could get one as long as complicated as that, but like I say, that's probably as hard as it gets when naming simple carboxylic acids. Okay, so that's a little AS recap, and the documents that your teachers have shared with you for the tasks this week go through a lot of the AS stuff as well. What I'm going to focus on now, though, is I'm going to go through some of the year 13 functional groups. And the key thing is, it's not about learning these straight away. All right, we're introducing them. This lesson is called Introduction to Year 13 Nomenclature. When you actually come across these individual homologous series in your regular lessons, your teachers will spend a bit of time just recapping, all right, how to actually name them. So I'm just introducing them to you now. So I'm just going to clear the board. And we'll start with nitriles. So, nitriles are an homologous series which contain that, okay, the C triple bonded to the nitrogen. Okay, so let's start, let's do a nice simple one. Let's make it 3. Okay, so how would we go about naming this then? Well, it is a nitrile, and there are 3 carbons in it. Well, the suffix for a nitrile, so the last part of the name, if you like, is, nice and easily, nitrile. It is nitrile. So, and then you just got to identify how many carbons there were. So how many carbons in the main chain with the functional group? There are 3. Okay. And now this is where students sort of like, well, it's 50-50. It's propyl nitrile or is it propan nitrile? It's one or the other. It's actually, in this case, it's neither. This is one of those rare occasions where, again, like before, like with the diones and the diols and the dioic acids, you have to include the letter E. So it's propane, get the letter E, nitrile. So it's propane nitrile, all one word, all joined up, all right? And then once you've identified it, any branches you name in exactly the same order. So what I'll do is I'll give you an example to have a go at here, all right? And we'll see if anyone can get the right answer. So let's have a go. Okay, so have a go at naming that. So using this, propane nitrile, and using your rules for naming branches and how you order them, okay? Name this molecule. Oh, very close. Jess Russell, very, very close there. In fact, so close. Absolutely spot on. Yeah, really well done. So let's have a look. How do we get a name this then? The longest carbon chain with the functional group we're naming is that. Okay, now which end do we actually number from? You number from the end with a nitrile. Nitriles are always at the end of the chain. So I'm going to call this carbon 1, 2, 3, 4, 5, 6. So it's 6 carbons. So it's hexane nitrile. Don't forget the E. And then I'm just going to circle my branches. So what have I got? I've got that, and that. That's a methyl, that's a methyl, that's chlorine. Okay, right? So which am I going to name first? I'm going to name the chlorine because it's alphabetically. So 5-chloro. So that ticks that off. And then I've got my 2 methyl groups. So it's 3, 4. 3, 4. Don't forget commas between 2 numbers and dashes between numbers and letters. Di, methyl, space that well. Hexane nitrile, all one word, no gaps. All right, your chemistry teachers and the examiners will penalise you if it looks like there's a gap. Usually there's a gap between the L in methyl and the H of hexane nitrile. So again, that's how you name nitriles. And like I say, there's a couple of examples how to go at in the work that's been said. We're going to move on then to look at amines. All right, so let's look at amines. And amines, there's a bone of contention with amines, as you'll see in the pack that I've shared with my class. So, okay. So amines contain this functional group. They are an homologous series, which is a family of molecules with similar chemical properties because they've got the same functional group. And the functional group is this. They're called amines because they're ammonia derivatives. So you can make amines from reacting ammonia with a multitude of different organic molecules. So let's have a go at naming them then. Okay. So how do we go about naming this? Well, the amine group. How do we name amines? What is the actual suffix of the name? Well, just like nitriles, okay, we ended with nitrile. With amines, we end in amine. All right. And then we've got to sort of think, right, so how many carbons is this? It's 4 carbons. All right. So we would call this, and I would call this definitely, butyl amine. But technically, if you check the International Union of Pure and Applied Chemistry, it should be butanamine. Okay? But both will be allowed. Your chemistry teachers might have their own preferences. I personally prefer the butylamine, propylamine, methylamine, hexylamine, that type of thing. So again, it's just be careful of that, which is why they don't tend to get you to name really complex amines. AQA really still go with this route, because I was looking at some old exam papers earlier, some recent ones actually, and they're still using words like propylamine, butylamine. So if it were me, all right, ignore the information that's in your actual pack that I've given you and focus on the aisles amines, if you like. So let's have a go then. If it was, because there's different types of amines, all right, primary, secondary, and tertiary. I'm not going to go too much into too much detail as to how to name secondary and tertiary, because your teachers will do that. There's a whole chapter of amines in year 13. But this is a primary amine. Now, why would you think we would call that a primary amine? All right, type an answer into the chat. Why do you think I've called this a primary amine? Use your knowledge of being able to classify organic molecules and come up with a reason. Why is that a primary amine? Absolutely spot on. Well done, Zoe. All right, it's because the amine group, which is this bit, is bonded to one carbon. So you can get secondary amines, things like this. Okay, so that is a secondary amine, and it's no longer NH2 because you're having to swap a hydrogen for an alkyl group, a methyl, ethyl, propyl, a hydrocarbon group, if you like. So this is a secondary amine. Why? Because the nitrogen is bonded to two carbons. Now, how would you go about naming this? And again, there's, it's up for debate this, but here's how I will always teach it, until I'm told otherwise. Is basically take the two groups and then name them in alphabetical order. So what have I got here? I've got a methyl group and an ethyl group. So I'd call this ethyl, because E comes before N, methyl, and then finish it with the word amine. Ethyl, methyl, amine. But again, they don't really get you to name really complex amines with regards to this. In some, I mean, again, another name you could give to this, by the way, is if they still accept in certain circles using the amine group as a prefix. So naming it as an alkane, but then using the amine group as a prefix. So other names you might see for this would be 1-amino butane. Okay, so there are different ways of naming it, and usually the exam board will allow the various different ones because chemistry teachers around the world are very entrenched in their own sort of methodology of doing it. So that's the amines. All right, and again, there's a whole chapter on amines in year 13 for you to look forward to. So we're going to move on now to looking at acyl chlorides. Happy days. Acyl chlorides. So acyl chlorides. Okay, so acyl chlorides contain this cockle group. So in structural formula, it would read as cockle. And then, so how are we actually naming this? Well, let's have a look then. They're carboxylic acid derivatives. All right, so they're derived from carboxylic acids. So let's have a look at a nice, I'll use a nice simple one. Again, it's not really an issue if you draw your carbonyl group pointing directly up and your chlorine group pointing to the right or down. I've just drawn it as that to show you that the geometry around the carbonyl carbon is actually trigonal planar. There are three areas of bonding there, so it's a trigonal planar geometry, which is why I'm trying to get that across. So how will we name this? Well, the suffix of these things is oil chloride. Yeah, so it's something oil chloride. So it's oil chloride. Well, what does this bit going to equal then? Well, here it's just the number of carbons. It's 2 carbons long. Don't forget to include the carbon, which is part of the functional group. All right, a lot of students do that. They seem to count from here. So I've seen people call this methanoyl chloride before. No, it's actually ethanoyl. Ethanoyl chloride. 2 words. Okay. Okay then. So I'm going to put another one up here for you to have a go at naming. I'm using skeletal formula as well. This is a good one. 2,2,3 trichlorobutanoyl chloride. Looks good to me. Looks very good to me, actually. Well done. Okay, so let's have a look how we arrived there. So we know the main part of the molecule is that, all right? So it's 1, 2, 3, 4. Acyl chlorides are always at the end of the chain, so they automatically become carbon 1. So this is butanoyl chloride. And then I've just got to fill in this bit here. Okay, so are there any branches that I need to identify? They're all the same branch, which is good. There's 3 of them. So it is chloro. It is trichloro, all connected. And then I've got to put the numbers in. So what have I got? I've got 2, 2, 3. Comma. 2, 2, 3 trichlorobutanoyl chloride. Why is this a nasty one, all right, for students? Is because they see 4 chlorines and they automatically think it's tetrachloro something, like a tetrachloroketone or a tetrachloroaldehyde. And they forget that that chlorine group is part of the functional group, okay? So that is all one group, okay? So just be careful because the examiners like to throw a couple of acyl chlorides at you every now and then. Okay, another carboxylic acid derivative is next, which is the acid anhydrides. So I'll get rid of this. Okay, so the acid anhydrides have this group. Okay, they have that. So they have that somewhere in the chain. So there could be a methyl group there, there could be an ethyl group there, and we'll talk about how we'll name it in a second. So let's have an example. Okay, so here's an example. Does it contain that group? Yes, it does. Okay, so it is an anhydride. How do we name anhydrides? Well, the suffix is oic anhydride. Yeah, oic anhydride. So now there's AQA actually go a little bit easy on you here because they only ask you to do symmetrical anhydrides. So you can see there's a line of symmetry there, which means that the number of carbons on either side is the same, okay? So you can basically look at this thing here. How many carbons does it actually have in the chain there is the same as it is on that side. So we call this, so if there was no symmetry, okay? So clearly see there's no line of symmetry down the middle, all right? You just basically look at either side. So I've got 3 carbons in a row there, so that's prop. I've got, 2 carbons in a row there, so that's eth. And then how would you name that? Well, you name the eth first. So it's ethanoic, propanoic, anhydride. All right, but again, they won't ask you to name those. They only seem to go for the ones which are specifically symmetrical in this course. So again, that's how you name anhydrides. Very similar to acyl chlorides. When we do the next topic on the carbonyl compounds, don't forget that a carbonyl compound is anything which contains that. Anything with a C double bond O is a carbonyl compound. Is this a carbonyl compound? Yes. Were the acyl chlorides? Yes. Aldehydes, ketones, carboxylic acids, all right, esters, etc., etc. Okay. Right then, let's have a look then at the esters. Let's look at esters. Okay. Now, in fact, no, I'm going to leave that anhydride up to show you a difference here. So So that's an anhydride. An ester is this. Okay? So be careful, because they do look very, very similar. The key difference is the anhydride has got this extra carbonyl group just here, whereas an ester could just have an alkyl group, methyl, ethyl, propyl. So I'm going to get the anhydride out the way for now, because I don't need it. Is an ester a carbonyl group? Well, does it contain the C double bond O? Yes, it does. Right, so let's have a go at this. Okay, so there's an example of an ester. So I've just whacked on 2 hydrocarbon extensions to the ester group. How do you go about naming it? Well, an ester has sort of, it's got 2 names. It's got a first name and a surname. And when you're naming them, this part here is the first name. Okay, and then this part here, including whatever's there, is the surname. So let's have a go at naming this one. So first name. So you're looking to the end of the ester, near single bonded to an oxygen. So it's that. So what group is that? That is an ethyl group. Yep. So there's the first name, ethyl. Congratulations. The surname then is all of this. Okay. So what do we actually call that? Well, it's got 4 carbons in it, so it's definitely bute. And it is derived from carboxylic acid. So it's a butan. And then how do we actually, so if it was 4 carbon carboxylic acid, it'd be butanoic acid. Well, a carboxylic acid derivative in the form of an ester is butano-8. Okay? So O8, butanoate, that's anoate. Okay, so it's ethyl butanoate. All right, so you name the tail first and the head second, as you might hear me say a couple of times. So let's have a go at one more ester then. All right, so I'm going to do an ester, but I'm going to do it in skeletal formula because it can be quite tricky when you see it like that. So, ooh, nasty. Ooh, good luck. Cetal has reliably informed me that my pens are actually quite squeaky, so I do apologise if it's causing you distress. Just put me on mute. Right, so we've got some answers, hopefully. Propyl pentanoate. Our survey says correct. So the tail bit is that. So it's the bit that's single bonded to the oxygen. All right. So it is propyl. Why? Because it's 3 carbons. And then the surname comes from the first part. All right. Which is 1, 2, 3, 4, 5. So it's pentan O8 with a gap. Sid raised a good point earlier in the chat that AQA like to sort of draw molecules in all kinds of different ways. And that's why I've drawn this one a little bit upside down, if you like. They could draw it vertically, back to front, all right? But there is nothing in an exam to stop you rotating your paper around until you see it's in a format that is more pleasing to you. And a lot of students actually find that quite useful, okay? So they're esters, and like I say, we'll learn a bit more about them next month, okay? And the final one we're going to look at is the amides. So let's look at amides. What does an amide have? Okay, so amide has this group. First thing is an amide a carbonyl group? Well, does it contain the C-rondo? Yes, it does. It's not an amine. Okay, if it just had NH2 and this was just, a hydrocarbon extension, it would be an amine. But because the NH2 is part of the overall functional group, it's an amide. Okay, so an amine doesn't have the carbonyl, an amide does. So how are we going to name these things? Well, right. Let's see if you guys can figure it out. So I've got 3 carbons and it's an amide. Any guesses? Our survey says, someone's written the word propanamide with no gaps, and that is absolutely spot on. Yeah, very well done. So, amides end in amide, and because they're carboxylic acid derivatives as well, effectively, it's propan, not propyl, so it's propanamide. Okay, so you can get propanamide, butanamide, pentanamide. So let's give you a trickier one, and there's one extra functional group I'm going to give you as well, one other homologous series, which is linked to this. So let's give you ouch. Enjoy. Do we have any answers? Yeah, absolutely spot on. Really, really well done, that. Let's have a look then. What is the amide we're dealing with here? Well, it's 1, 2, 3, 4, so it's butan. I know I'm going to need a lot of space for this. Butanamide. Butanamide. Brilliant. And then I've just got to get all my branches, and there's quite a few branches here. So I've got, and there's names. So I've got an ethyl group, I've got a methyl group, I've got chloro, and I've got another chloro. So there's 3 different groups here. So which end am I number from? Well, just like with the carboxylic acid, number from the amide end. So it would be, which I'm going to name first alphabetically. I've got C, M, E. So it's going to be the chlorines first. So it's 4, 4, dichloro. So that ticks them off. What's next? Ethyl or methyl. E comes before M, so we're going to go with 2-ethyl, and then 3-methyl butanamide. Obviously, they will not give you one that complicated to actually name in the exams because they usually only give you one line to write on for this. And that would, even I struggle with that with small handwriting. Okay, so well done if you got those. All right, let's have a look at one final one, which is an amide derivative. So it's similar to an amide. Okay, and these are called N-substituted amides. Okay, so what exactly do they look like? Well, let's have a look. I'm just going to get rid of this. All right. Well, that's an amide, an N-substituted amide is that. All right. So I've swapped a hydrogen from the amide group with an alkyl group. So an R group is an alkyl group, methyl, ethyl, propyl, etc., etc. So how do we name this thing? Let's draw one. Okay. So again, if that was a hydrogen, this methyl group here, it would be propanamide. So this is definitely a propanamide derivative, but it's not exactly propanamide because I've swapped something onto the nitrogen, which is why we call it an N-substituted amide. The N stands for nitrogen. So we have substituted a hydrogen for something else. So what have we actually swapped our hydrogen for? What do we call that? It's a methyl group. So we call this N-methyl, all one word, propanamide. So that lets anyone know in the world of chemistry that it's propanamide, but there's a methyl group on the nitrogen. And that's pretty much it. They're the molecules you'll come across in year 13. All right. Hope you found that useful. Like you say, yeah.